Now we see that we have an inequality that's in standard form. So before we can graph, we cannot do the cover-up method in linear inequalities because then it gets confusing about where to shade. So the first thing we want to do is go ahead and I gave you that box to work in. Go ahead and rewrite the problem. So work with me. I want to get y by itself so I know which way to shade and what my y-intercept and slope are. So I'm going to go ahead and subtract the 3x from both sides. And just like in tutorial number 0, what we talked about is writing that negative 3x first and then the 10 behind it. That's the same thing. Negative 3x plus 10 is the same thing as 10 minus 3x. Just like in your calculator, 10 minus 3 would be the same thing as negative 3 plus 10. So we can write it either way. And we're writing it this way because it makes it easier to graph by putting the term with the x in it first. All right, we're dividing everything by negative 2. Oh no, we're dividing an inequality by a negative number. That means that my lesson sign is going to change. Don't forget that. So we have y is greater than. Now see this negative 3 over negative 2? We want to keep our slope as a fraction because fractional slopes are the best. We see the rise, we see the run. But I know that when I see a negative over a negative, they're going to cancel each other out, right? If you don't believe me, you can pick up your calculator and hit that fraction button, put negative 3 in the numerator, negative 2 in the denominator, then hit enter, and you'll see that it'll give you 3 halves. The negatives cancel each other out. And then 10 divided by negative 2 in your calculator gives you a negative 5. And now that we've rearranged our inequality that was in standard form into this form where we can see the y-intercept and the slope, it's just easier to graph, right? So our first point that we're going to graph is our negative 5. And then we're going to use our slope up 3, 1, 2, 3 over 2. We have our 2 points. We have to stop. We are not just going to mindlessly draw a line that connects those 2 points. We have to stop and say y is greater than this line, not equal to it. So because there's no line underneath the greater than sign, I know I have to use a dashed line to connect these 2 dots. And the second thing I need to do is decide where to shade. Y is greater than this line. I'm going to take my pen or pencil. I'm going to put it exactly on my y-intercept. That's why I'm drawing the y-intercept extra big. And I'm going to say y has to be greater than this y-intercept. So where are the numbers that are greater than negative 5 on the y-axis? That's right, the numbers that are moving up. So I'm going to shade up above the line. All right. I shouldn't be quite so, there we go, make my shading a little bit better. All right, let's try one more. I think that's it. Oh, no, that's not it. All right, let's try one more. Same thing, we're given an inequality in standard form. We want to rearrange things so that y is by itself. And the way we rearrange is the same every single time. We're going to get rid of the x term from the left side. We're going to make sure we put the x term first and then the leftover number second. Then I'm going to divide both sides, all terms, so both sides, but all terms by negative 3. Oh no, we divided by a negative. We're going to flip that inequality sign. Once again, same thing here, negative 5 divided by negative 3. We don't want to change that to a decimal. That would make it more difficult to graph. We want to keep it as a fraction, but that negative over negative actually cancels out. So end up with 5/3 x. Then negative 15 divided by negative 3 gives you a positive 5. So once again, after we rearrange, we're going to use that information to graph. Oh no, when I put my y-intercept as 5 and my slope is up 5/3, I have to make a choice. I can extend my graph. Now I can't because I don't have enough room on this smartboard, but I could, if I was on paper, extend my graph so I could go up 5/3. But there's also a trick. If you run out of room moving up, you can do the opposite of your slope moving down. So you know how we would go up 5 to the right 3? Well, let's do the opposite. Let's go down 5, 1, 2, 3, 4, 5, and to the left 3. When you do the opposite of your slope, instead of going up and to the right, if you go down and to the left, you still end up with a line that has the slope of 5/3. All right, so can I use a solid line to connect these 2 dots? Absolutely. All right, let's do the shading. Y is greater than or equal to this line. So we're going to put our pen or pencil on the y-intercept, and we're going to say our y-intercept is 5. Looking at the y-axis, where are the numbers on the y-axis that are bigger than 5? That's right, they're the numbers that are going up. So therefore, I'm shading up above my line. Now, I'm going to tell you something. If you don't do that little thing where you put your pen or pencil on the y-intercept, you might start shading incorrectly, because just looking at the x-axis, the numbers that are bigger on the x-axis, we would be shading to the right, right? We don't care about looking at the x-axis unless, like one of our last problems, we have something like x is greater than 4. All right,